Hello, everybody. I'm going to share my screen here so we can get started. All right. Today we are going to build a real-time dashboard over Kafka. I'm going to be using Confluent, but we're going to build a real-time dashboard in Grafana with Kafka, and we're going to cover a lot today. So I'm going to launch right in. If you have questions, feel free to ask them in the YouTube chat. I'll answer them as I can. I've also got somebody kind of in the background here helping me. Jim is going to help me out answering questions. So again, if you have any questions, feel free to ask, as they come up. And let's jump in here. So I want to talk just first of all who I am. My name is Cameron. I'm the content lead at Tinybird. I've been an engineer and a project or a product manager at an IoT startup in my prior world, I guess. I've been at Tinybird for about 2 years, but I've worked in data and analytics for a little over a decade now, and so I should be roughly qualified to run this live stream. And if I'm not, I guess we'll find out. But yeah, let's jump into what we're going to build today. So this is a very basic kind of diagram that shows what we're going to do here. And so really, I mean, if you look at the ends, we've got Kafka that's going to be streaming some data, and then Grafana that's going to be visualizing it. And in between, we're going to be using Tinybird. And what Tinybird is going to do for us is it's going to provide a connection or an ingestion service for our Kafka data. It's going to write that data into a database. Tinybird uses ClickHouse under the hood. It's going to write that into this table. We're going to build some SQL queries over that then we'll create APIs with that Grafana will consume. This will be kind of where we start. And then what we'll do is at the end, I'm going to introduce some optimization techniques. We're going to use Materialized Views to create some dynamic rollups so that we have a performant dashboard no matter what. But one of the things I want to talk about before I start building, I promise I'm going to start building soon, but I want to talk about what I mean by a real-time dashboard, because I think that can mean a lot of different things to a lot of different people. When I'm talking about a real-time dashboard, we're talking about analytics here. We have high query complexity. So that means we're going to be doing things like filters and aggregates. We're not going to do any joins today, although that's something we could also include in that. But in the real-time component, we're talking about data freshness. So what that means is in our dashboard, we want the data that's visualized to have been created in very recently, like in the past few seconds. And then what we also want is that when we refresh that dashboard, that we're querying that database and we're getting that data in milliseconds. And ideally, we want that in under 100 milliseconds. We really want a snappy user experience in this dashboard. And then we won't really demonstrate this today, but this is something also when you think about user-facing dashboards, we want to be able to support high concurrency. So we want to be able to support a lot of access, a lot of concurrent queries to that database. So we need to handle that. And then the other thing that we're actually going to show a lot today is just how you handle historical data. So we're not going to just build a kind of a real-time dashboard today that's just looking at the most recent data. We're actually going to build something that can respond dynamically to analyzing historical data and bringing historical data into that dashboard. And those are kind of the components. One of the things I want to emphasize today is that we're not using a cache. We're not going to run our analytics and then push them into like a key value store or something. We're gonna query the database. And the reason we're doing that is because data is constantly arriving. And so we really can't afford to cache because we always want to display the most recent data. So we're not going to be doing that. So with that, let's jump in here. I'm going to get out of these slides. And a couple things I have up here. This is a Tinybird workspace. I'm going to jump in here in a second. This is an empty workspace. I have a Confluent Cloud cluster, which is what I am using to stream data. And I have this topic that's called Clickstream. And actually, if we kind of look at one of these messages, I'm streaming about, 135,000 messages an hour. So it's not a lot, but we're definitely streaming data. And you just look at the schema here. You can see we've got the timestamp. the session ID, this is like a very basic payload for some web analytics or something like that. And then I'm using Grafana local today. We'll build our dashboard in here. You could obviously do this in Grafana Cloud, but I'm using local for this. So let's start in Tinybird. And the first thing that we want to do is start capturing that data from Confluent. So I'm going to create a data source. And what I'm going to do is I'm going to select this Confluent connector, which will allow us to really quickly ingest that data from Confluent. You can see a lot of other connectors that we have and some guides on, kind of building your own and things like that. But we're going to do Confluent today. And all I need to do here is get some of these details. So the first thing I'm going to grab is the Bootstrap server from my Confluent cluster. And then I'm going to give this a name. I'm just going to call it Confluent. And then I'm going to grab my key and secret, which I'm not going to share with you. And if I click next, now I can see I've connected to my Confluent cluster, and I have this, this topic, that clickstream topic. And I can define a consumer group ID here. In this case, it doesn't really matter, so I'm just going to use this default because my key has global access, so I don't need to worry about sort of setting up access to a consumer group. And then I'm going to click next. So when you connect to a Kafka topic in Tinybird, you can get the earliest records, or which means all the records that are on the topic, or you can get just the records until you make the connection. So I'm going to go ahead and select earliest. I've been doing some testing with this, and we've got a fair amount of data in this data source. And basically what you'll see is Tinybird just analyzed that topic, and it's now kind of parsed that out into a table. And what it will do is it will analyze the data that's coming in and sort of infer a schema. So you can see things like I've got some of this metadata that's coming from Kafka, and then I've also got these payloads in the message. I am going to set this timestamp instead of as a string, as a datetime 64. You'll notice that Tinybird's warning me, that's saying, hey, you might send some rows to quarantine. And that's okay. I trust that my choice is right here, namely because I'm the one who set up this data source. And then the other thing we're going to do is we're just going to make sure that we are sorting by timestamp. So again, Tinybird uses ClickHouse under the hood. ClickHouse is a columnar data store. And so when we set the timestamps, the primary sorting key, what we're basically saying is, I want you to store this data on disk sorted by the timestamp, such that if we filter by or aggregate over that, over that timestamp or group by that timestamp, we won't have to access the whole table. And I'll show that here in a second. So let me call this, I'm just going to call this events. And then we're going to create this data source. And it has been created. We'll get a little refresh here. And we'll see some events showed up. And also you'll see some rows went to quarantine. What does that mean? So I was playing around with the schema in my Confluent topic the other day, and I actually tried sending a different schema, but I decided to use something else. So that data is still in the topic. So what Tinybird does is, instead of like dropping that or throwing an error, it'll push it into this quarantine. And so there's actually some helpful things that you can do to take that data, reformat it so that it matches the data source schema, and then you can push it back into that data source. I'm not going to do that today because it's a little bit time consuming, and all the recent data will match. But I should, I think, have about like 25,000 rows. Yeah, they go into quarantine. So you can see this data source now has about 830,000 rows. It's not a ton, but it's not a little. And so we'll kind of see how that shows up. Okay, so the next thing we want to do is start to query this data source. And in Tinybird, you do that with a pipe. So I am going to create a pipe, which is essentially just a kind of a chained series of SQL nodes. And what I want to do is I'm just going to do like a very basic pipe. We're not going to get like super involved on the queries here. But what we're going to do is just do an SQL query that's going to give us, like, for a particular time interval, what is the total number of new sessions that were created in that time interval. for the sake of time, I am going to copy this SQL in here and kind of explain what it's doing. This first node, so in Tinybird pipes, you have this concept of nodes. So we can kind of create a first node and then query over that node in subsequent nodes. So all this node is doing is it's creating some time series data. And what you can see that, basically is happening is it's taking the last 5 minutes and chopping it up into 5-second intervals. And then it's kind of creating this empty time series. And the reason I'm doing that is if for some reason in my actual web data, I have gaps, I'll basically join this time series to my real data, a left join so that, I don't have any gaps in the data. So that's what's happening there. We'll come back to this in a little bit. And then the next one, this is where I'm going to actually count the unique sessions for this interval. So basically what you see here, what I'm doing is I am getting, these 5-second intervals and using this ClickHouse function, which is unique. It's kind of like I count distinct. But this is actually an approximate number. There's a function in ClickHouse called unique exact, which will give you the exact distinct count, but it's a little less performant. So I'm just going to roll with unique. And then I am getting this data from the last 5 minutes. And actually what you'll see as I run this is, remember this events data source has 835,000 rows, but since I've filtered by timestamp, I'm not processing or I'm not reading the whole table. If I, commented this out, you'd see, I just scanned 840,000 rows. Pretty impressive. Tinybird still returns this in 22 milliseconds, but it's not something we really want to do. So we have that filter there. I'm going to call this, I'll just call it current sessions. And then the last node, really just to join these nodes together, and so we get our our time series with this look back without any gaps. And you can see this is UTC times. We're actively streaming in this data, and we're getting these counts. And as we stream, that's gonna update. And I'm also formatting this. I'm explicitly formatting this date time as a UTC string. There's some Grafana reasons for that. Time zones are hard. Dealing with date times is always difficult. So by explicitly formatting it as a UTC timestamp, I can overcome some of those things. So I'm going to name this node endpoint, and this is kind of my final result that I want. And this is the fun stuff in Tinybird, because now I can create an API from this node, and I just did it, and it's done. And so you can actually see this sample usage. I've got this URL for this HTTP endpoint. I can pass my token. Feel free to read that and copy it. I'm going to delete this resource at the end of this anyway. But then you can also kind of get this in different formats. So, if I copy this and I just paste it into a browser, okay, you can see I'm getting this data. And as I refresh, we'll see that new data gets updated. And so we now have this API. And so what we're going to do is we're going to integrate this API into Grafana. And so the first thing we need to do in Grafana is create a data source. And actually, before I do that, I just want to acknowledge, I know when we were, I sent some emails about this and said, hey, we'll build a dashboard with like Next.js. And my goal for this was to build like this internal dashboard in Grafana and this kind of user-facing dashboard with like a Next.js using some React components. I realized I wasn't going to have time for that. And so we're just going to do this in Grafana. But I think the important takeaway here is like, this is an HTTP RESTful API. So integrating it into something like a Next.js application is really easy. And in fact, we have a lot of blog posts, examples where we've done that. And I will share those in a follow-up email after we finish up here. But let's create a Grafana data source. And you can see I've got some old ones here, but we're going to add a new data source. And for Tinybird, we're using this JSON API plugin. This is now maintained by Grafana. So it's just a great way to ingest from a JSON API. And what I'm going to do is I'm just going to grab this API here, and I'm going to drop it in here. And then I'm going to add an HTTP header to pass my token. Make sure I spell that right. Error. And then I'm going to go ahead and create a new token. And I'm going to give that token, what we'll end up doing is kind of give this a read scope for all the APIs that I'm going to create today. For now, we just have one. But I'm giving it this reading the pipe, the sessions pipe, giving it that scope. So let me copy that token, paste it in here, and then okay, cool. No last pass. Great. So we have this data source. And actually what I'm going to do is I'm going to drop this. I'm going to cut this. I'm going to save this for later because I'm going to pass it in the query in the dashboard. So actually, if I save and test, it's going to fail because the token does not have access to this endpoint. But don't worry, we will fix that. So let's build a dashboard. So we're going to create a dashboard and add a visualization. I'm going to use this data source that I just created. This is kind of the name of the plugin. I guess it was developed by Marcus Olson. So we're going to click that. And then I'm going to take that path of that API and put it in here. And so that will kind of point to that particular API endpoint. And then we're going to define the field. So if we go back to this API in Tinybird, we can see we have this data object, and within that we have these timestamp and TS and C key value pairs. And so that's what we want to access in this panel. So let's just we're going to do data, all that, and then TS. This is a time, and I'm going to call this interval in my Grafana panel. And then let's do the same thing for that count. And okay, great. We are getting data. There you go. And then this is just a number, and I will call it sessions. And I'm going to call this live sessions, the panel. So you can see that. And I'm just going to do some formatting here for fun. Add a little fill there. And then, okay, you'll notice something. I'm refreshing, and it's not adding new data. That's because by default, this data source will cache the response. But again, I don't want to cache the response. I want to continue hitting the database. So I'm going to set this cache in Grafana to 0 seconds. And then if I apply that and refresh, okay, so you can see this new data is streaming in here. And actually, I'm going to set an auto refresh. You can set it to 5 seconds, but it's not super real timey, right? And so there's something you can do in a Grafana dashboard. First of all, let me just save this. We're going to call it real-time dashboard. If you go to the dashboard settings, you can set these refresh intervals. And I'm going to set mine to 1 second. Let's do it at the beginning. I'm going to add this 1 second. Now, I can do this because there's a setting in the grafana.ini file when you install this, when you install Grafana locally, that you have to change. I'm not going to cover that right now because I don't want to dig through the files, but you can find that, just Google minimum refresh interval on Grafana, and you can set that setting. And so if I save that and go back, I can now set it to refresh every second. And that's what it's going to do. So every second, it's going to kind of stream in this new data. And let me just make sure that it's continuing to produce. That's awesome. I'm gonna ramp things up a bit on the producer. So we should start to see a few more sessions come in as we're streaming. There we go. So you get this idea, right? We have now created this live dashboard, and that's pretty much it, right? We've just built a live dashboard. Of course, there are going to be some problems here. Performance isn't a huge issue right now. In fact, if we go back to Tinybird, we can look at this API and there's some observability here. But you can see because we're only looking at the last 5 minutes, we're processing less than a megabyte of data. It's not that bad. Our latency is, sub 20 milliseconds. Like this API is performing great for this use case. But what if I wanted to look back, right? Let's go look back the last 30 minutes. I don't have any data because if you remember, we're filtering in the pipe, we're filtering to only get the last 5 minutes of data, which is making our query efficient. But it also means I can't look back. And so I'm gonna modify my API so that it will dynamically get the amount of data specified from Grafana. So if I change the look back, it will change the filters in my API to get that data. And so we're going to use Tinybird's query parameters to do that. So again, I'm just, for the sake of time, going to copy and paste and explain the SQL here. Let's start with this first node. Okay, let's format this, make it pretty. Okay, so what you are seeing here is I'm defining a start and an end. And it is basically saying, give me, these double curly braces. This is how you pass a query parameter to a Tinybird API. So you can define these in your SQL. This query parameter is called start time. I'm setting a default value, but I'm also saying that it's required. So I'm creating this interval, or rather I'm creating this timestamp, and then I'm creating this, end timestamp, start and end. I mean, you can see I'm using this parse date time best effort. We'll take a string input and parse it into a date time, and then I'm doing the same thing here, creating that range, but I'm passing these start and end values that I've defined. Age is basically like a date diff in ClickHouse. So if I run that, you'll actually see these default values from 1935, 1940 on March 8th. You can see that's the time series that I'm getting here. So we're dynamically passing. So if I change this to, well, I guess we don't want to start after an end, but let's just say I change this to 9. We'll get a lot more data. I'm not going to show that, but you get the idea. We're dynamically passing this parameter, and so we're going to update this one too. So I'm going to, again, copy my SQL. And not much changed here. The only thing that really changed is that, again, we are dynamically setting this, the look back. So now we're giving it a start and end. And again, it's going to do that. I had some old data when I was testing, so you can see now that's showing up here based on these defaults that I've passed. And then actually this last node doesn't change because it's just doing that. It's just doing that join. And so now if I go back to my panel, it's broken because I need to, and actually, I mean, I guess it's not broken, but it's passing this default data. So what I'm going to do is I'm going to update my query parameters, or I'm going to add some query parameters in this data source query. So you remember, if we go back to the API, we have, Tinybird will tell us hey, you have these two parameters. They're called start time and end time. And what we're going to do here is we're going to pass these from Grafana. And we're going to use some Grafana global variables. So if you use this from, and I'm going to format it as an ISO, that will take the from time on the state picker and pass that. And then same thing here, end time. Let me just copy this, paste this, and we'll call this 2. 2. Okay. So if I apply that, and let's change the look back to 5 minutes. So then it's going to, we're back at that view that we had earlier. But now, if I look back 15. You see it's dynamically updating. It's retrieving, the same amount of data for, it's retrieving the data dynamically. Sorry. So that's cool, right? Like now we have this thing that's kind of accessing historical data. We can change our look back periods and get this dynamically by passing those parameters. But one thing we got to be worried about here is performance, because again, the longer that look back period, the more data I'm going to be asking for from that data source, which is going to start to get a little bit ugly. And I'm just, because I am a little bit OCD, I don't like that this is just jumping around. So I'm going to set the default to the access minimum to 0, because it's just jumping all over the place and it's annoying me. So now we have a little cleaner dashboard. So I'm worried about performance. And one of the nice things about Tinybird is that when you create these resources, Tinybird gives you the ability to build some observability APIs. So you obviously have this built-in observability in the app, but I want to build my own. And so I'm actually going to create a pipe. And instead of using a data source of my invention, I'm going to use a service data source. So you can see I have all these different service data sources. And I can query these in Tinybird, and actually queries to these data sources are free. And I'm going to use today PipeStats RT, which is PipeStats real time. So if I look at this data source, basically what you'll see is I have a row for every API request that has been made to every pipe in my workspace. And so what I want to do is I want to know how much data this API that I've created is processing, and also its latency. And so I'm going to, again, copy and paste my SQL for the sake of time. But I want you to just, see what we're doing here. We're getting the start date time of the request, again, formatting it into these intervals, and then getting the average read bytes, which is the amount of data being processed by the API, and then the average latency of that API. And then I'm doing where pipe name is sessions, because that's the pipe that I just created. So if I run this, basically you'll see I'm getting this time series that, 5-second intervals over the last, since this pipe was created, is showing me, process bytes and latency. And so I actually want to visualize this. I'm going to add a panel in my Grafana dashboard to visualize this data. So I'm going to set up, well, first, let me create an API from this. Call it API performance. And I'll just call this an endpoint. We only have one node here. Okay, let's grab this API path, and we're going to pass it in here, and then define this field. So that same thing, we had and actually this data source will it will suggest, and actually again, we don't want to cache here. If we do the query inspector, we can actually see that query. Oh, okay, so look. This token doesn't have access to this resource, right? Because I created that token. And what I actually need to go do is go back to my all APIs token, add a pipe scope for this API performance, a read scope, and save that. Now, if I go back, okay, cool. Now I'm accessing that API. So let's add a process bytes and a latency. What did I call it? Latency, right? Yep. You can actually see Grafana is like making recommendations, which is kind of nice. And then, how did you do that? Yes. Okay. And there you go. Okay, so we're getting that data, and basically every time we're making a request to that API, this data is going to show up. And let's just call this series is processed, this series is latency, and this is interval, and this this is obviously our time. Let's do some formatting on this so that we can, see what's what. So I'm going to kind of do that same thing. I like that layout. We're going to set a color scheme. And I also, because latency is so much smaller than process bytes, I'm going to create a field override in Grafana to move that to the right axis. So we're going to create a field override for latency, an override property, which would be, let's see, which one is it? Axis placement. And I want to put it on the right. Okay, so now I've got a right axis for latency and a left axis for process data. This is confusing because they're both red. So let me add another override here, standard options color scheme. And I'm gonna make it, Okay, so let's apply that. I'm gonna move these things around and open that up. Okay, so now you can see that as Grafana is making requests to that sessions API here, I'm now monitoring the latency of the and the amount of processed data here in Grafana for this API. And actually, I'm gonna again just do some set this minimum to 0 because it's a little bit easier to see. Okay, so now we're going to see something by look back 30 minutes. This is going to let's fix this. I'm gonna basically decouple this performance panel from the time picker, so it's just always going to show me the last 5 minutes. It's just a little bit easier to see. But you can see how when I change this to a 30-minute look back, the process bytes, which is red, went up from about a megabyte to 4.5. Not great. If I look back 2 days, we're going to see a similar, massive. And so now we're processing like 40 megabytes of data, and that's really not awesome. Fortunately, my latency is still really good, but I'm using a lot of compute, and so that's something that I want to fix. And so that is going to be kind of the last thing we do in this screencast is we are going to fix this performance problem with some roll-up. And so what we're going to do in Tinybird is we're going to use materialized views, which are kind of like a specialized data source that will pre-calculate things like aggregates at ingestion time. So when you look at this dashboard that we've built right now, we're calculating all of these aggregates at query time. And so the more data that I request, the more expensive the operation, the more I have to calculate. And so what we're going to do is we're going to pre-calculate our aggregates as roll-ups, and we're going to use those roll-up kind of data sources that we create with materialized views to improve the performance of our dashboard. So let's jump into that. What we're going to do is we're going to modify this API, but the first thing that we need to do is create these roll-up data sources. And so in Tinybird, to create a materialized view, you basically do the same, create this pipe. You create a pipe, and I'm just going to call this roll-up 5 seconds. So what we're going to do is we're going to create 5-second roll-ups. So it's going to take, the number of unique sessions over the last 5 seconds. We're going to create a 1-minute roll-up, and then we're going to create a 1-hour roll-up. So what we're going to end up doing in the dashboard is we're going to say, like, if our look back period is 30 minutes or less, use the 5-second roll-ups. If it's between 30 minutes and a day, use the 1-minute roll-ups. And then if it's more than a day, use the hour roll-ups. So my first roll-up will be this 5-second roll-up. And this is going to look like this is a very basic bit of SQL. Let me just paste it here. This is going to look very familiar. basically just calculating, to start an interval, basically these 5-second intervals get that. And actually, you'll notice that state modifier. I'll explain that in a second. That's something that Materialized Views will do. Or just, again, unique count, count of session IDs over these 5-second intervals. This is doing a full scan, not great. What we're going to do is we're going to create a materialized view from this. I'm just going to call this node rollup. And then I'm going to go and instead of create API endpoint, I'm going to create a materialized view. And I'm going to call this materialized view rollup 5-second MV. And so what you're seeing here is it's going to store, my interval ST, and then it's going to store, what's actually happening is it's storing an intermediate aggregate state. So it's basically maintaining the state of this unique aggregate. And that's why what TinyBird will do when you create a materialized view from a query is it will kind of automatically add that state combinator to the end of your aggregate functions. But if we were doing this manually, like in ClickHouse, we'd have to add that. And then you can also set your your sorting keys and things like that. We want our sorting key to be based on the time. So we're going to click next. We can do up to 2 million rows, all the data, new data only. We can even match an SQL condition on what data we want to go into this. I'm going to just get all the data. I have less than 2 million rows, so I just get that. And now I have created this data source called rollup 5-second MV. What the heck? What this is, what's going on here? These are characters that make sense. Again, it's not storing the aggregate, it's storing a state, an intermediate state. And when we query this materialized view, we're going to merge that the state to get the final aggregate. And so I'll show that in a second. The first thing we want to do is we want to create 2 more rollups. So I'm going to just duplicate this pipe. I'm going to call this rollup 1 minute. And then instead of to interval second, well, actually, why not? Let's just keep it second and we'll do 60, right? And so now this is going to get minute intervals and calculate those same intermediate states. I will create another materialized view, create a new data source. I'm going to call this rollup 1 minute MV. Everything is the way it needs to be. Click next, create a materialized view. And then let's do one more for our 1 hour rollups. So we'll just do 3,600 seconds. And there you can see we're getting these hour rollups. And we're going to create a materialized view. And roll up 1 hour MV. Boom, done. Okay, so I now have these 3 new data sources with each of my rollups. So what I want to do is change my sessions API to pull from these rollups, and I want to do it dynamically. There's a lot of I say a lot. It's not a lot, but it's a lot for the time that we have. A lot of code here. So again, I'm gonna do my copy paste hack. My hands get cold when I do live coding sessions, and I'm stuck at typing. So this saves us all time and energy. But let me explain again what's happening here. So if you remember, we're passing those start time and end time query parameters. And what we're going to first do in this CTE is basically create a filter. So we're calculating the number of minutes between the past start and end time. So that's going to be our filter. It's just going to be the number of minutes in the specified interval. And then when we start, we're going to do the same thing, but we're basically going to say, okay, look, if this filter value is less than or equal to 30 minutes, then create a 5-second interval. If it is if it's not less than 30 minutes, but it's less than a day, then create a 60-second interval. If it's not, then a 1 hour interval. And so we're doing that for start and end. And then we're doing the same thing here with that kind of time series. And so you'll actually see if I run this, it fails. And the reason it fails is I haven't passed a default value. So I can set a default value in the API, or I can use some TinyBird magic here to set the the value temporarily. So I'll just do 2024, 3, 1, 2, and what time is it? It's about 16. I'll just do 16:30. And then I'm going to copy this for my end time as well, and I'll just set this to 1640. And if I run that, you'll basically see, okay, now I'm getting this, this interval. And because I specified an interval that was less than 30 minutes, I'm getting 5-second intervals. Now, if I do something like go more than an hour back, and I look at this, now I'm getting those 1-minute intervals. And then if we wanted to go back more than 24 hours, I'm going to get those hour intervals. So that's that dynamic roll-up that we're doing. And so we're again going to modify this node, and this is going to look like a lot when I paste it, but I will explain it. Don't worry. Format it, make it all pretty. Okay, so here's what's happening. We're doing that same thing. We're calculating the filter, same thing we did in that first step. And then what we're doing here is we're selecting from this roll-up 5 seconds materialized view. You can see this merge combinator here on the aggregate function. So we're taking that aggregate state that's stored in the materialized view, we're merging it into a final count. And then what we're doing is saying, where the data is between that defined range, and also where the data is less, where the filter is less than or equal 30. So this select statement will only return results if my filter value, which is the specified time range, is less than 30 minutes or less than or equal to. And then basically what we're doing is just a union all for these different rollups. And so now it's saying, hey, select from the 1-minute MV if my filter is between 30 and 1440. And otherwise, if my filter is greater than 1440, select from this hour MV. So based on the time range that gets specified in Grafana, 2 out of these 3 will return empty results because the filter condition won't be satisfied. So we're basically just going to dynamically pull from these materialized views based on the look back period. If you're confused about this, I know it's a lot of code you're looking at, and it's maybe a little hard to understand if you're new to rollups or materialized views. There's a blog post that my amazing colleague Allison has written that does exactly this. And I will share that in the follow-up email so you can kind of see the whole walkthrough. You can see the GitHub repository, and she even built a nice little UI in Retool to kind of show how it all works. So I'll send that. You can look at that if you want kind of more details on how this work. And again, if I run this, it's going to fail because I need to set the value of these parameters in the node. And so there we go. So now you can see I'm getting these hourly intervals for the parameters I passed, and then this this node does not need to change. Okay, so we should be good there. The last thing that we need to do is go back to our dashboard, and broke everything. And that's because my query parameters changed. Or rather, what did change? I guess something changed in my panel. Let's look at it. TimesCMC, yeah, what changed in my API? Oh, I know what changed. So I'm setting these values manually I'm manually passing query parameters. So if I zoom to the data, it's going to zoom to the parameters that I'm passing there. So what I'm going to do is I'm going to pull these set statements out of my nodes. And it is going to error in Tinybird. I'm not worried about that. Because when I go back to Grafana, it's fixed. And again, what we're doing is we're passing the start and end from the state picker back to Tinybird. Now, we're looking at the last 5 minutes of data. I'm seeing, the averaged processed and averaged, latency And you actually, if you notice already, when we were querying that raw data source, we were calculating those aggregates at query time, and I think we were processing like a megabyte of data. Now we're processing 9 kilobytes. So like, what is that? Almost 3 orders of magnitude less. And that's because we're now querying the materialized view, which is maintaining those aggregate states and constantly updating them as new data is ingested. And so now if we do an hour look back, again, that threshold is greater than 30 minutes. We'll now see that we're getting 1 minute rollups, right? So now we're rolling up this data every 1 minute, and the process data increased a little bit, but I mean, relatively speaking, not a lot, right? So we're still at 60 kilobytes versus we were at like 4 megabytes. And if we go back 2 days, now we can see we have these hourly rollups. And of course, I only used 1,000 unique session IDs in my generator, so it's maxing out at 1,000. But actually, this now we're only processing like 2 kilobytes of data because these rollups are, there's very few points in this materialized view for the time period. But I could even look back like 30 days, and I don't have a lot of data because I just started working on this you can see when I started working on this. But again, it's just we're processing very little data. And so now we have this nice dynamic rollup, super performant dashboard, does not process that much data. Our latency for this API is staying below 10 milliseconds or 80 milliseconds, no matter what. It's actually looking more at like 40 milliseconds. So really good latency characteristics for this API. And that is pretty much it. That is kind of how you build this live dashboard in Grafana. Now, basically, to recap what we did, I think that's maybe helpful. The first thing we did is we connected Tinybird to this Confluent cluster, which I've been logged out of. We're streaming this data into this Confluent Cloud cluster, which is what we're using for Kafka here. You can see how much data we're producing into this cluster. So we connected that to Tinybird, and this raw events data source has about 1 million rows now. It just keeps ticking up. And we created this sessions API. Now we did that in a very unoptimized way. And actually, I'll send out the GitHub repo for this work in an email in about 30 minutes or so. And it actually in that repo you have a pipe for every phase of optimization that we did, so you can kind of see the differences in the code and see what changed. And so we started with kind of something that just looked back 5 minutes and it created 5-second intervals. That was fine for a live dashboard that only looked back 5 minutes. But then if we wanted to change that look back period, it didn't dynamically update. So then we added those dynamic changes, but we had some performance problems. So then at the last bit, we used Materialized Views to create some performance improvements. And the cool thing here, again, I want to reemphasize, like, we're not using a cache. We are not pre-calculating our analytics in a traditional sense. Like, we're not pre-calculating these in some big OLAP, like Snowflake. We're not pre-calculating these in Postgres. I mean, we're pre-calculating them in ClickHouse using materialized views. And so the way the materialized views work in ClickHouse is that they're calculated incrementally. So every time new data hits, it's going to continue to calculate that new aggregate state. And we'll actually merge those states in the background, but then we also, we basically do a manual final merge in our query. And it just massively improves the performance of our dashboard, because now instead of calculating all of our aggregates at query time, we're moving that to ingest time. And instead of doing that for every query made on the database, we're doing it once. So this is especially valuable when you start to get to high concurrency situations where you're building user-facing analytics and you've got, you know, I hope that you build your application and it scales to, 10,000 users who are all actively using it every minute, and they're just nailing that API. Materialized views are going to be a great way to maintain that performance. And hopefully, as you saw in TinyBird, those are really, really easy to build. And then just kind of like going back to the fundamentals, why did we use TinyBird? Besides the fact that I work for TinyBird and this live stream is hosted by TinyBird. TinyBird is built for these kinds of use cases because our goal is to have that end-to-end, data ingestion to data query, latency measured in like seconds or less. And that's what we've achieved. So we have this streaming infrastructure in Kafka that's constantly sending data to TinyBird, and TinyBird being a platform that's built on top of what I believe is the world's fastest OLAP database, is able to handle these analytical queries really well. And so it's just like a perfect use case for, it's a perfect platform for user facing or even internal, but where you need these real-time analytics visualized for your users. So yeah, I mean that's pretty much it. I guess we were a little early. Maybe I could have done Next.js dashboard. I don't have the infrastructure set up to do that, and I'm not going to spin up a Next project right now. But again, I'll send a follow-up email with some resources. The other thing we didn't show today was like adding new data sources. It's like a really common thing would be if you're streaming events from like in this case, we're streaming clickstream events from a website. Maybe we'd want to enrich that with data from our CRM or something like that. We want to, look at campaign data and pair that up with UTM codes in our clickstream. TinyBird makes it really easy then to add data sources from, BigQuery, Snowflake, S3. So like maybe we have a CRM that's storing, data in S3 or some kind of object storage. That's a really easy process to then bring that into TinyBird and enrich the streaming data with these dimensions. We kind of scratched the surface of TinyBird. This is like a very basic optimization use case. There's so much more that you can do here. TinyBird is free to try. The build plan is really generous. So if you want to play around with this, highly encourage you to go check it out, sign up for free. I'll send a link to sign up. Yeah, that's it. I'll also send the GitHub repo. You'll have access to that. Any questions? I'm happy to answer some questions in the time that we have. I think we have got about 5 minutes of time left. If there are questions, you can ask them in the YouTube chat. If there aren't, we'll just shut it down. I'm going to take a sip of tea. Okay, I don't see anything. I don't see any questions. But let me open up my slides here, just so you have. Hey, if you want to get in touch with me, here's my email address. I'm doxing myself, but I'd be happy to hear from you. I'm not the smartest guy at TinyBird by any stretch, so if you have a really complex question, I'll either try to answer it myself or forward you on to somebody who's smarter than I am. And also, if you want to connect with us, check out our Slack community. We have a public Slack community where you can ask questions and things like that. Again, I will include a link to that community in the follow-up email. Yeah, cheers, y'all. Have a good day, and talk soon.